Hello, everybody. We're going to start the webinar today. The topic of the webinar today is Internet of Things and Device Management. We're going to talk about various protocols for Internet of Things for clients and on servers. My name is Ohad Oman. I'm VP of Products of Friendly Technologies. The agenda for today is I'm going to give you a very brief introduction of who we are at Friendly. And then we're going to talk about the differences, a little bit of introduction, a little bit of background about IoT and device management, because basically everybody has different notions of what IoT is. So just so we can be on the same level and talk with the same terms, we're going to discuss IoT, Internet of Things and device management. Then we're going to delve a little bit into the various protocols that are available. Talk about the differences between them, what each of the protocols is good for, when should you use each of the protocols, the advantages and disadvantages of each one, both for device management and for IoT. And then I'm going to show you what an ideal IoT platform should probably look like due to the needs of device management and IoT. And then we're going to end up with a little summary. Let's start. So starting with the introduction. Friendly Technologies, to those of you unfamiliar with us, is quite a veteran company. We were established in 1997, which makes us on our 21st year already. Our legacy, our core business for years now, for more than 11 years, was device management for the telecommunication industry. We were doing the device management platforms and servers for major and less major telecoms around the world, allowing them to manage the end devices at the customer's premises and the network devices, which means that for a while now we've been talking to devices, to things, really over the internet, which makes us IoT experts, only it wasn't called IoT until a couple of years ago where everybody started to talk about IoT. For device management, for the device management part, we have over 200 global installations. When we're talking about global installations, we're talking about normally an ISP, XSP, a telco company, so some of them are running millions of devices on the same network. So we come from that world and we know what we're talking about when communicating to things over the internet. As I mentioned, over the last 2 or 3 years, everybody is started to talk about the buzzword called IoT. And when it comes to IoT, there's some slight differences between device management and IoT, and we ramped up our technology and our knowledge and our capabilities to a complete IoT solution. And I'm going to talk about the differences between what was the classic device management and IoT in the upcoming slides. Again, my name is Ohad. I'm the VP Product Management at Friendly. This is my email. If you have any further questions, because there's going to be a lot of people on the webinar today, and I don't think we'll be able to address every specific question. I am going to leave some time for questions in the end, but if you have any specific concern or question, feel free to contact me at this email, and I promise to get back to you. Okay, this is just a partial list of some of our customers. You can see some major tier 1 customers there, both in telco and in IoT. I'm not going to go through this, but just as a reference. So let's talk about IoT and device management. When people say IoT, you'll find out that a lot of people are talking about a lot of different things, and I think I can put everything into 3 categories really about what is the Internet of Things, or what are the things that are controlled by an IoT network. So this is the big things is the world that we're coming from. When I say big things, I don't mean big physically, I mean big in complexity. So this is the world of device management for telcos, for example. So you have the routers and you have the more complex stuff, but also industrial IoT and connected cars, things like that. These are things that have no problem with power. They're always connected to the internet, or most of the time connected to the internet. They're not really concerned about bandwidth, and their data model is very complex. It might contain thousands of different parameters to be controlled. So this is the big challenge. This is really more closer to the world of classic device management. Now when IoT came along, there's a lot of simpler, smaller things that are connected to the internet, mostly sensors and smaller devices. And these things um, are have a lot of things in common that are different than the big things because they are smaller. They have smaller memory, running memory and program memory. They have smaller bandwidth because a lot of times they are connected over a SIM card and bandwidth is expensive. And they have low power. Sometimes most of the times they're operated on battery and they need to go to sleep. So these are the small things that are connected directly to the internet. And in these things, most of the functionality is the set and get functionality, which makes their data model less complex. So a light bulb, for example, doesn't have thousands of parameters to control. There's on, there's off, there's dimming. Maybe it can tell you what the power consumption through it is, but that's about it. So a smart light. So this is the example of the small things. And then this is the more interesting scenario, I believe, and this is the scenario that's probably going to dominate the IoT world. We already see it happening. These are the things that are called IoT, but they're not really IoT because they don't have the I part in them. They're not internet connected things. There are things like Zigbee, like Z-Wave, like LoRa, like Sigfox, like BLE. All of these protocols that I just mentioned that are considered to be IoT protocols are not IoT because they don't have an internet connection. In order to make them an internet capable devices, you need a gateway in the middle. Now, most people view the gateway just as a means of transferring between a non-IP protocol and an IP protocol. So this is just like a pipe. You take a device, it doesn't have internet, you give it internet capabilities, you bring it up online, which is true. In a lot of cases, it is true. So, for example, if you have a very, very small installation or just a device that is connected to your smartphone, then you don't really need to consider the smartphone anything else other than taking this device online. I'm going to show you in the next slide why this is a little bit more complex than this. But all of these non-IoT devices that are working through gateway, what you need to consider is their data model is just as simple as the small things. There's not a lot of things to control over there. But then when you take the gateway into consideration, things get a little bit more complex, and especially when you're talking about scale installations, because when you're a service provider, when you want to deploy an IoT network, when you want to give an IoT infrastructure, there's going to be a lot of these gateways in the middle. So let's concentrate a little bit about the gateway architecture and the complexities of it. So in this kind of installation, there's the basic IoT platform. Everybody that will come and tell you they have an IoT platform, normally what they mean is they have capability to do set and get on the end devices, so to collect data from them and to control them. And from the IoT platform end, there are portals maybe sometimes where you can see inventory. You can most of the time do big data or BI analysis, rules and automation and connect applications to it. And sometimes, most of the time, you can do some basic firmware update. Again, not necessarily to the end devices because a lot of them don't have the firmware update capabilities. When we're talking about IoT and device management, it gets a little bit more interesting. So an IoT and device management platform, first of all, there's the gateway device management in the middle. So don't forget that these things are quite big, quite complex. They're collecting data from sometimes thousands of tens of thousands of devices. Their data model, the amount of data that they're holding is both complex and dynamic because there's always the add and remove components. You need to be able to do diagnostics and repair because these things there might be millions of them across like a state or a country where some of them might be far away. You don't want to need to send a technician. You do an IoT installation, this thing should hold for tens, if not, more than that, of years, and you need to be able to configure things from a central location. This is not simply like, when you have a simple smart building installation and you are the owner of the building, you are the one that is managing it, you can just log into the gateway embedded web page, configure whatever you need to configure, and that's it, you're done. But when you got millions of those, you're not going to log into the web server each and every individual gateway. So you need to be able to get diagnostics and repair functionality. You need to get alarms and alerts. You need to be able to configure them, do a mass firmware update, for example. I'm going to show you examples of this later on. Security is a very, very big concern because now with the cyber world and the cyber attacks, you need to be able to monitor the configuration of this gateway. Don't forget that the end devices don't have really a data model or anything to configure, and they're not the ones that are going to be hacked into. Your gateway is where the hackers are going to target because this is your first point of entry that has an internet connection. And if you're just viewing this as a pipe, if you're not monitoring what goes through the gateway, then you have no way of preventing or predicting that there's a cyber attack on these gateways, for example. And of course, provisioning and everything else. Even with the firmware update, in this kind of functionality, you need more advanced firmware update. You need group operations, you need scripts, you need things like that. And you need service provider tools. Let's talk a little bit now that we said about what is device management and what is pure IoT, let's talk a little bit about the protocols that are involved in each. So before we start, I'm just going to give you the bottom line of everything. The bottom line is that there are 4 main protocols that are being used now for both IoT and device management. There's some variations of this. Some of these are being used in proprietary ways, but in general, there's MQTT, which is the most prominent IoT protocol. This is a very fast, very light. It's a messaging protocol. It's a pub subscribe. I'm going to explain this in the next slide, what I'm talking about when I'm saying a messaging protocol. But this is a very fast thing. This is very similar to what you have in your WhatsApp or chat applications. This is sending a message, it being received on the other end very, very fast. But this is an IoT data protocol. It's not a device management. So you can turn your light on, turn your light off, even do dimming because it's very, very fast. So, you press the dimming button and you see it happening in real time. But this is not a way to manage IoT devices. Lightweight M2M is it's a lightweight protocol. It's by the OMA board, the Open Mobile Alliance. It's a lightweight protocol. So it's fast, it's light, but it's a structured protocol. So it's a session-based protocol. I'm going to explain that too in a second. So this is a protocol that allows you to do a lot of the IoT functionality, but it also gives you light device management functionality. Just a second. OMA-DM. OMA-DM again is from the Open Mobile Alliance. This is a device management protocol devised for the mobile applications. So it's for things that are on the move, things that are not over a fixed IP, things that are not or dynamic IP, but stationary. It's a more complex, it's a more structured, it has a lot of the functionality. Again, I'm going to show the difference between all of these in detail in a second. But this is a device management protocol for the mobile world, a device management for IoT as well. So these would be used for telematics, for mobile gateways, for things like that. TR69 is the world that Friendly Technologies is coming from. This is probably the most mature and the most complex device management protocol. It was devised by the Broadband Forum. It's being ruled by it. It's very, very widely accepted worldwide. There's millions, if not, hundreds of millions, if not even billions of devices around the world that are TR69 capable. But it's a heavy protocol. It's very structured, and it's meant for fixed devices that are stationary. So this is just the bottom line of what we're going to talk about. Keep this in mind when we go through the details. Before that, I promise to talk about what is the difference between a messaging protocol and a session-based protocol. A messaging protocol is a protocol that basically does pub subscribe. Pub subscribe is that there's a broker. You can view it as a bulletin board, message board, where anybody in the network can publish a topic to the board. Anybody else can subscribe to that topic. So what you're really doing is you're disassociating the thing that sends from the thing that receives, and both of them can send and receive. So they don't need to know about each other, they just need to know about the messaging board, and it's very, very fast because the messages are short. There's no session being opened. So somebody just publishes and that's it. It's kind of set and forget. There's a little bit more complexity to it because there can be quality of service and it can get assurance of that things were actually sent, but you have no visibility about who reads them at the other end. So the object is a topic, so the topic can be the power on for the light bulb that is in room number 3 in house number 4. This can be a topic. And then you can say on or off. This is just an example of what an IoT message would be in an environment like this. But you need to keep in mind that even though it's very, very light, it's fitting for battery operated, low bandwidth applications, it doesn't take a lot of footprint. It's a messaging, the messaging protocol is just a language. Out of this language, you need to build words, you need to build sentences, you need to build stories. If you want to do firmware upgrade, for example, using a messaging protocol, it gets quite complicated because you really have to reinvent a whole protocol out of these building blocks. Some of the common messaging protocols that you might be familiar with are XMPP, CoAP, and MQTT. MQTT in the current day IoT world is the most mature and most widely used. So companies like, I don't know, Amazon Web Services, for example, they're using MQTT, but they've built a whole proprietary, non-standardized language out of these building blocks of MQTT. So this is not, MQTT is a standard, but the way MQTT is being used is non-standardized. A session-based protocol, on the other hand, is normally very, very standardized, at least the ones we are discussing, which are lightweight M2M, OMA-DM, and TR69. So the downside of this is that every transaction is a session, which means that normally the client is the one that initiates a session to the server. It goes to the server, it asks for a start of a session, then there's some keys, some information exchange, some verification, and you close the session. So you open a session, you do the transaction, and you close the session. This is a payload. This has some load on the server. So this takes a little bit more time than just sending your message and forgetting about this, but this gives you a lot more reliability. In this case, the payload, normally the payload is like what is being sent, the actual data that's being sent during the transaction, depending on the protocol, is either an XML or a SOAP message, as opposed to MQTT, where you can send pictures, you can send files, you can send whatever, or you can send just like 1 bit of data. But the advantage is that it's an established protocol, so the business logic is set, it's known, it's being used. For functionalities like firmware update, you don't need to reinvent them. You just say, update the firmware, and everybody knows what to do. Everybody knows what it means. Everybody knows what is being handled. The data model is of a known structure. It's very standardized. Every client and every server can negotiate between them. Common objects are predefined, so you don't need to invent new. This is already a language. This is already language, words, sentences, stories. Everything is already set and predefined. There's a lot of flexibility within that, but the basic things are, writing a set, doing a reboot functionality, for example, is the same across the board. It does have, as I mentioned, some load, and it's a little bit slower, but mature platforms, like the TR69 platform or the One IoT platform that Friendly is offering, is already proven to manage like 20 million devices or even more than that on the same platform. So it's handleable. There are ways to achieving this. So there is a load, but professional systems know how to handle them well. One thing you need to, I'm going to discuss a little bit later, is that in order to achieve this, the client is the one that initiates every transaction, but the server can do a push. So the server can say to the client, I got something to tell you, please approach me. So this is a bidirectional initiation, but in general, the initiation is always from the client side. So this is a quite complex table. I'm going to go through this in detail, and you'll see it's not so intimidating as it looks like, but this is a basic comparison between the different protocols. As I mentioned, MQTT is a messaging protocol, while the other three are session-based protocols. This means that the messaging doesn't have any overhead. Lightweight M2M has a lighter overhead than the other protocols, so initiating a session might, if you need to, on a case-by-case need, but it can be lighter. You can send something without doing all the heavy transaction. The OMA-DM and the TR69 are a little bit heavier on the transaction, on the overhead. The footprint for MQTT is very, very light. Very light. I think you can fit it in 10 or 20K even if needed. Lightweight M2M is a little bit heavier, but again, it's lighter. It's less than 100K in code. The OMA-DM and the TR69 needs some memory resources, again, because they're designed to handle more complex tasks. The server load, MQTT is light, a very light server load. Actually, there's also almost zero server load because there's no real server. It's more of a broker. You get a message and that's it. You don't do anything with it. There's a server that sits on top of this that is a subscriber to these messages, and this it's putting the messages that it's receiving into a structured database. Lightweight M2M, again, it's a lighter server load. There's not a lot because the transactions are small. The data model that are being handled are smaller, and OMA-DM and TR69 are heavier server loads. As far as data model, MQTT, as I mentioned, it's just a language, so it doesn't really have a data model. You need to build a data model on the fly while you're structuring it. So there's no, you can't really, well, you can, but you need to reinvent it. Basically, an MQTT is just a messaging protocol, so there's no real data model. Lightweight M2M, OMA-DM, and TR69 are structured data models. So it looks like a tree. There's a topic, there's a subtopic, there's a subtopic. Each one of them have their own parameters that can be set or get. You can perform set or get on. TR69 is even a little bit more structured than the rest. I'm not going to go into the details here. This is not within the scope of this session. But the complexity of the data model is, again, with the lightweight M2M, you can handle hundreds of, tens or hundreds of items per data model. In OMA-DM and TR69, you can do thousands of them or even more. Dynamic means that if something changes, if the server requires a change in the data model, the server cannot really affect the data model of an MQTT. So let's say you want to open another instance, open another room. In TR69, lightweight M2M and OMA-DM, you can do this. The server can expand or reduce or modify the data model. MQTT, because there's no real data model, it's not something you can do. Firmware upgrade. With MQTT, you need to reinvent your firmware model. You need to do something proprietary. Firmware upgrade, sorry. In lightweight M2M, OMA-DM, and TR69, firmware upgrade is one of the basic functionalities of the protocol. It's all an object or an instance or whatever it's called per protocol, but it's all set and predefined, including what happens during a firmware update. So the messages that if, let's say, a firmware update failed, and it failed because of it didn't find the file, or there was not enough memory, or all of these things are set as part of the protocol. Whereas in non-structured protocol, you can do this, but you need to write it in code. So really the bottom line is MQTT is not really a device management protocol, even though some people are building the proprietary device management functionalities out of it. but lightweight M2M and OMA-DM can be used for device management or are used for device management, and TR69 is the most mature one for device management out there. As far as response time though, this is where MQTT takes the lead. Response time for MQTT is very, very fast. So you can do like volume up and stop when you get to the right volume, for example, whereas in session-based, you wouldn't be able to do this because, I mean, lightweight M2M is quite fast. It takes under, it can take under a second for a command to get to the other side. But with OMA-DM and TR69, you know, it can take even up to 10 seconds sometimes for a transaction. So you're trying to do dimming, you do, you know, dim down, you press it once, and then you press it 10 times, and you're not going to be able to see the response, so you might overshoot her. So these, for these type of functionalities, you know, when you need something very, very fast response or real-time response, it is real-time, but real-time within a few seconds and not within sub-second. So the bottom line of this, that the common use for MQTT is for sensors and for small and constrained devices. This is what it's fitting for. Lightweight M2M, again, same thing as MQTT, but lightweight M2M can also manage small gateways or collectors, gateways that you have a few devices that are connected to it. OMA-DM is for mobile gateways, for telematics, and TR69 is for fixed gateways or for complex gateways. As far as protocol comparison, as far as the basic functionality for those a little bit more tech savvy among you, so all of them have the push functionality, so all of them can, the server can ask or somebody can ask a device to give it the messages. All of them have an option to be discovered or provisioned, but MQTT, again, it's unstructured. You need to write the provisioning protocol on your own, whereas provisioning is a very, very basic skill of the more structured protocols. All of them can do GET, all of them can do SET because this is IoT. For boot and reset, again, this is a structured thing for the structured protocol, and you need to do it on your own in MQTT. Diagnostics, TR69 is a highly diagnostic protocol with a lot of sub-protocols that are contained within it. Change notification is if something changed. Let's say you're doing a water meter system, but you're seeing that there's a leakage. You're detecting that there's a higher rate of water consumption. You want to notify about this. All of them can have the capability of doing this. Again, with MQTT, you need to be a little bit proactive about it. Application management, because OMA-DM was designed for mobile phones, this is the most highly application management skilled protocol. TR69, you can do some level of application management, while lightweight M2M and MQTT are just simply too light, too basic to do that kind of thing. And with the protocols that are from the Open Mobile Alliance, the lock and the wipe is a very basic skill of them, where TR69 and MQTT are not designed to do that type of functionality. But I think TR69, there's some way to work around it. As far as security, all of them are somewhat secured or more or less secured. TR69 is a very highly secured protocol because it was designed for telcos. So is the OMA-DM. Lightweight MTM is also supporting certificates. So you can send the certificate and you can verify who's on the other side. With MQTT, you got all the security about the encryption of the transaction, and you can run it over VPN, and you can make it secure. The more secured, by the way, you make MQTT, you lose a lot of the fastness and the functionality of it. So you can build a very secured protocol over MQTT, but then it would just be as slow as some of the other protocols. As far as reliability of communication, what is called sometimes quality of service, or making sure that the message that you sent actually got to the other end, was understood, you know, and was acted upon. So TR69 and OMA-DM are designed for that. Lightweight M2M, you can set the level. So for example, lightweight M2M, you can put it, there's several levels, I think 3 levels of use mode. in Lightweight M2M. By the way, also in MQTT, where some of them are less reliable just to take advantage of the best effort that you get over, for example, when you're working over a SIM card. So you don't want to bother about making sure. You're saying, I've sent the command. If it got to the other side, fine. If not, no. Or you can set it to a more highly reliable level, so it's configurable. Okay, so we said, I'm talking now about the more structured protocols, the session-based protocols. We said there are standards. They are regulated by governing bodies. They're widely accepted, everybody's using them, which means that every client or every device that is employing them can connect basically to any server without too much of a modification. There are some advanced functionalities, some proprietary functionalities in all of them, but the basic set, the set, the get, the provision, the firmware update, the reboot, the basic functionality is common to all of them. So obviously there's some open source clients for device manufacturers that they can use out there. And these open source clients comply with the regulation. So why not use these open source clients? Well, the basic answer is you can if you want to do some experimentation, if you're some home user, some maker, some hacker, something like this. If you're a device manufacturer, there's these things are simply too basic. So they comply with the rules, but they're not optimized and they're not meant for mass production. There are carrier-grade clients. Friendly offers, I think, for these three, also a carrier-grade client that for device manufacturers. This is not our main business. This is not where we're coming from, but we found out that because we know how to build a server right, we know what is needed on the other end, and some of our customers came to us asking for these clients, so we devised them and we made the carrier-grade client. So a carrier-grade client has more features than the basic ones. Each of these protocols have a basic set of features and a more advanced, again, regulated, but set of features, and then there's some unregulated set of features that just gives you more functionality when both the server and the client support it. So there are advanced features that are in carrier-grade clients. They're optimized for footprint, so they're smaller in size because we have more experience. They're optimized for transaction time. So, there's a session. If it takes the client more time to respond, then it takes more resources, more load out of the server, and it's less fitting for deploying hundreds or thousands or tens of thousands or even millions of devices on the same server, because each one will, even a fraction of a second more, means less devices and more problems on the server side. You get upgrades when you get when you're buying a client, you get the upgrades when the standards change or get more features. You get service and support, and you get also server access for your R&D team to deploy it. Professional server access for bringing it up on your device. So here's a sample architecture of how an IoT installation would look like, and just to give an example of each of the topics that we've discussed so far. So this is the main server. This is the IoT platform. Everything in orange is the part of the IoT platform. A very basic thing is a lot of the devices that you need to integrate already have some sort of IoT. Let's say a lot of times they would have an MQTT protocol connected to their own cloud. So let's say this is agriculture and this is some ground humidity sensor that is already installed in the field or that you want to buy from an external source. So a good IoT platform would have a cloud-to-cloud interface. So they have their own cloud. Their cloud has an API, and the server should know how to do through WebSockets, through through REST API, a RESTful API, should integrate to a third-party cloud and just get the data. Obviously, you're not going to do the device management, but you can still get the ground humidity data out of it, or you can turn it on or off. If it's your own, if it's something that has a protocol like Lightweight M2M, you can integrate directly into your system and control it. Again, get the set and get, and also if it has any device management functionality, but this is Lightweight M2M for a sensor. It's probably not going to have too much to control here. Now it gets more interesting because a lot of these installations work through a gateway. In agriculture, and specifically because these are large areas, a lot of times what they do is that they have sensors that are talking through some RF protocol. Let's say BLE is getting to be a more common one. And a farmer can drive using his gateway or even a tablet or a phone and collect the data through when he's going through the fields. He will just collect the data of the various sensors that are out there, or you can go, so it's not a fixed sensor. This is a mobile sensor. In this case, you'd probably use an OMA-DM protocol to manage the gateway, and the sensors would be through some sort of RF. But the most common thing, and the thing we're seeing most from agriculture companies, is this scenario. This is actually an interesting one because it starts with a collector. A collector is a device, let's say in this case LoRa, but it can be Sigfox, it can be lightweight narrowband IoT, any of these protocols. But a collector is something that you can connect devices directly to it, so it supports a lot of legacy agricultural devices pre-IoT era, that they might have I2C, SPI, some CAN bus, some other type of wired bus to the collector. So this collector can be connected to a few sensors, maybe to an irrigation system, something like this. It would communicate over some non-IP IoT protocol. So like LoRa, for example, is a very, very common one for this, to the gateway. And the gateway would be managed probably by a TR69. We're seeing this more and more. A lot of gateway manufacturers are coming to us asking for TR69 capabilities for their gateways. It's something new because LoRa is not about gateway connectivity. It's more about collecting the data, and we're adding the gateway. And from this, once everything is on the server, then you can do it. I'm going to show you all these other capabilities of an IoT platform next. So let's talk about IoT platforms. This is the typical IoT platform, a fully ended IoT platform managing both data and device manufacturers. On one hand, you have all the sensors and the devices and the gateways. You might have third-party connectivity. So an interface through some sort of a smart layer to other third-party devices. And here on the server side, there's the big data, there's the monitoring, there's support portal. I'm going to show you what I'm talking about. There's administrator portal that you can manage the assets. And on the other end, there's a smart API. Now, dealing with something like this, you don't want to need to write a different application for every single protocol that's on this side. So using a smart API, you're really doing an abstraction layer, or sorry, not abstraction, normalization of all the APIs. And when you're writing an application, when you're doing some sort of interface from the applications or from the backend to any of the devices, you really want to be agnostic of what's going on this side. This is how we're doing this on Friendly. This is the Friendly server, the Friendly IoT platform, for example. So on the south, on the devices, on the south end, you got interface through a smart layer where you can have one of these protocols that we discussed, or proprietary protocols when you do abstraction. And on the northbound, you got a smart API. So when you write, let's say, a smart city application, when you say turn on the lights, all you do is you write turn on the lights on this end, and this decides if the light is a LoRa connected light or a specific proprietary connected light. It doesn't matter, you can switch. Also, we have an application generator, which is a required thing when you're doing large-scale installations, because let's say you're doing a smart city and you got a variety of gardens. Every garden, you'll have to write its own specific application if you're trying to code it. But if you got an application builder, an application generated platform, then you can make changes on the fly. You can do a basic drag and drop or wizard to create a specific applications and use them either on a mobile device or on a fixed device. So this is just the general architecture. This is Friendly's the device management and IoT platform, where you can see all of these things. So you need a self-support portal. If somebody's trying to see if he can reconfigure his own own gateway, do some basic reset or reprovisioning. You got a provisioning portal, so new devices don't need to be entered manually. You got a call center because a lot of the IoT installations are IoT as a service. You have an administrator console because you need to manage all of these devices, do group actions. I'm going to show you in a second. QoEs like big data type of devices, finding what is the quality of the connectivity to the devices, or the getting some business intelligence, event management. This is like this is where the applications are built into the functionality, the automation, NBI for CRMs, for back office devices, also for external applications, BI report generator, and cybersecurity, which is a new addition, a very, very important functionality that allows you to monitor, because you're monitoring the configuration of the devices. This allows you to monitor and detect cyber attacks long before they happen. This all goes through the smart layer, and then on the other side, by the way, there's also back functionality for SNMP. There's other, or HTTP, which is file-based devices, device management, and some other ones that you can add. And on the other end, there's the vertical applications like IoT devices, smart home, but also our legacy, which is managing CPEs, customer premise equipments, devices like this. Okay, so this is the admin console. This is just a sample of what an admin console should be like. You see all of the devices that are on your network. There can be millions of these, and it lets you either go into each one specifically, so go into the specific CPE, or you can manage them in groups, or you can define KPIs for monitoring, or you can divide events, or generate reports, or manage the files of any of these. So just a little highlights, this is for managing a specific CPE. You can get a device info, you can get all of the data model of the device with collapse expand, so you can see every single parameter that every single specific device on a network is doing on one hand, or you can go to update group and do group functionality on it. I'm going to explain about this in a second. For a specific device, you get all the skills that it can do, and you can even use them from buttons. So you can trace a device, you can reboot a device, you can set a device to factory reset just by clicking a button, because again, you don't care what the device is. If it's using a standardized protocol, then it's very easy to do any of these functionalities because it's supporting them by definition. Even reprovisioning, replacing a device. You can do big data collection through reports. You specify a KPI. So you can say, for example, I want to monitor one of these parameters every 1 hour across all of the devices in my network, or across all of the devices on a specific street or in a specific installation. Okay, this is actually an interesting device. Just as an example, this is a smart home gateway that you're seeing here. That is working over actually over TR69, and it has both device management and the IoT data all in its data model. So everything you see here is the diagnostic, is the device management functionalities. It has a Wi-Fi access point. You can specify firewall functionality. You can specify what is the IP, all the things that don't have to do with the data, but with the gateway itself. And everything here is actually the data, the key knob, the meter, the multi-switch sensor. All these data you can see as data points and collect them. So these type of things can be managed by an MQTT, and together you get a full picture of the functionality of the device and the devices of the gateway and the devices that are connected to the gateway. So let me give you an example of what an advanced group update would be. So in the case of no device management, let's say just a normal IoT, firmware update would be send the FTP of where the firmware file is and ask the device to report to you once it's finished. And again, a lot of times they don't even do this, but ask the device to tell you if it was successful or not. With advanced device management, you can specify a group of devices to be updated together based on the model, the geography, the firmware version, any filter that you want to add, and define a group. You select a script for the firmware update. So you can ask it, every device in this group can do a reset, back up its configuration file, do the firmware update, do another factory reset, and do restore of the configuration file, for example. For each and every one of these devices, while letting you know what is the progress of this script, of this group update, what are the reasons for failure. If there are reasons for failure, you can specify only to do this between 1 a.m. and 2 a.m. on every Tuesday, because these devices are not used. You can do it on 100 devices or 1,000 devices at a time. You can say, do this every 2 hours, every 1 month, let's say you want to do a reset, just a simple reset once a month, so you can specify the repetition conditions, how many devices that failed that you want to raise an alert and stop the process because something is wrong. You can say only do this on online devices. Do you repeat if it failed? Things like that, and again, reports and statistics. So this is a mature IoT platform functionality. Don't forget that IoT, most of these times, is going to be IoT as a service and not IoT as a project. So IoT as a project is more like M2M. You go to a factory, you do some automation functionalities, and that's it. Or if you buy your own smart home out of the store, then you get a smart home as a product, not as a service. But if you get the smart home from the service provider, or when you're doing a LoRa network, you need to provide service. So if you provide a service, you need a support center. You need a call center, where the call center can go and look into every specific device and try to help you with it. Change the password, do a reset, find out what are the suspected, the immediate suspects for basically provide tier 1 support on this, and even a little bit more than that, because you can do firmware upgrades for individual devices. You can change the parameters. You can basically see all of the data models. So whatever is exposed on that device, the customer service representative can see it. Of course, there are different levels and different skills of CSRs, of customer service or technicians. So you can specify, that some of the technicians are not going to be able to do all of the functionality, just basic ones, and the experts will be able to get access to more devices like this. Again, a good IoT platform should have a portal for customer service, or at least an API for customer service. Big data is, of course, BI and monitoring is a major part of every IoT platform, because IoT is mostly, don't forget, we're discussing a lot of the device management functionality, but at IoT, the bottom line of an IoT platform is about the data. IoT is about data, so the big data and analytics. For example, we implemented Sisense BI and reporting into our platform. Didn't reinvent the wheel, we're just using a very high professional one in our platform. But again, there's also an API and KPIs that you can produce for external, more advanced or more proprietary, or something that you are already using. You can just get the data straight out of the system, but the reporting system, the monitoring system is very, very advanced. So you can get every data of every parameter in our system on every frequency that you want, up to millions and millions of devices and data points. We even adding our own IoT builder. This is an example of what an IoT of our IoT builder and how it looks like. So you can build your own applications using a very simple wizard without having to write code, without having to outsource this functionality to an external, or having engineers and designers do it. So it's just a drag and drop. You got basic functionalities like mapping, or if this then that, if you see this sensor let's say if the temperature drops below a certain thing, give me an alarm, or automatically turn the air conditioner off, or do any of these functionalities, of course with clicks, and it goes on mobile devices, and it goes on desktops or on dashboards. So you can build dashboards, you can build applications for specific streets in your smart city, or for specific branch in your supermarket chain, or anything like that. And you can modify it just with the drag and drop, so you don't need to recompile, resend. It's an HTML5 applications that are running on every device. So we're down to the summary part of our discussion. Just IoT and device management platforms, what are the benefits of it? So we mentioned, don't just manage the data of your IoT, also manage the devices of your IoT network. Have functionality of alarms and notification, not just from the sensors and devices, but also from the gateways, so you know when something is going wrong or about to go wrong, or you're under a cyber attack, or a device is going to run out of battery or things like that. Use standardized protocols and servers because there's a lot of experience and common knowledge and maturity beyond it. Use carrier class devices because God forbid you become successful and you don't just do 500 devices installations, but you do 5,000 or 50,000, and then you're going to run into problems if you're using something that is not carrier grade, and you want to be backward compatible from the beginning. An end-to-end platform should have admin and service portals, should have big data, should have BI, should have applications, APIs to external professional services like a CRM or other SaaS applications. You need to be, again, depending on your need, but everything now is on the cloud. But a lot of times for security, for cost, for other purposes, you want to be on-prem or you want to be on a private cloud and not just on a public cloud. Public cloud is definitely an option. It's becoming very, very popular, but then Amazon is taking a big chunk, or Microsoft or whoever is running your public cloud is taking a big chunk out of your profits. And if you're a service provider, you want to get service provider-oriented platforms that know your needs and your specific requirements, as mentioned. This is more or less the basic presentation that I have prepared. I think, do we have time? What time is it? Yeah, we're just about run out of time, even exceeded it by 5 minutes. If you want, I can stick around for another 10 minutes if you want to write questions if I find out how to open this thing. If not, my email again is ohad.oman@friendly-tech.com. You can send me questions, or you can send questions through your contacts. Thank you very much. I'm here.